All right, guys. So in this video, we are going to put everything together and actually calculate a two-sample z-test for a difference in population proportions. In the last three videos, we kind of pieced each thing together. So let's run through this example together now. The Helsinki Head Start or Heart Study, excuse me, recruited middle-aged men with high cholesterol levels but no history of other serious medical problems to investigate whether a cholesterol-reducing drug could lower risk of heart attacks. The volunteer subjects were assigned at random to one of two treatments. 2,051 men took the drug gemfibrozil, call that GEM, to reduce their cholesterol levels, and a control group of 2,030 men took a placebo. During the next 5 years, 56 men in the GEM group and 84 men in the placebo group had heart attacks. So we want to know, did the results of this study give convincing evidence at the zero point zero 0.01 significance level that GEM is effective in preventing heart attacks? So again, the first thing that we need to do is the state step. We're going to have to perform the four-step process here for a significance test. So remember, we're going to state our null, an alternative, we're going to define the parameters, and we're going to state the significance level. All right. Even though they said the significance level in the setup of the problem, in our four-step process, we still need to include that as well. So here we go. We want null, where P sub G minus P sub PL equals 0. So we assume there is no difference. And then the alternative is that the difference is less than 0, where P sub G is the true heart attack rate for middle-aged men like the ones in this study who take GEM, and P sub PL equals the true heart attack rate for middle-aged men like the ones in this study who took the placebo. Use significance level 0.01. All right, notice how detailed the context was given when we stated the parameter. Do have to be careful with that. Make sure that you state it concisely. So that's the state step. Remember, we're going to go state, plan, do, conclude. So the next thing we're going to do is plan it, which we're going to say which test we're going to use, and then check the conditions for it. Okay, so here is the plan step. We're going to do a two-sample z-test for a difference in proportions. We're going to check the random condition. And we have to state, again, you can't just put random and then a check mark, that volunteer subjects were randomly assigned to GEM or placebo. Now, because this is an experiment in which where randomness was introduced was in the assignment to treatments, you don't have to check the 10% condition because the subjects in the sample were not sampled without replacement from some larger population. Okay. But had they been, then yes, you would have had to show the check for the 10% condition. Then for the large counts, first thing we're going to do, since the null assumes that there is no difference, you have to calculate the combined proportion. And then you have to get the number of successes and failures for each sample based on that combined proportion, not the sample proportion, and show that they are all greater than 10, of which they are. So the next thing we want to do, that state plan, is the do step where we actually calculate the p-value. All right, so the first thing we're going to do there is look at the z-score. So for this, we will calculate the proportion for each sample. So p hat sub g is 0.0237 and p hat sub pl is 0.0414. Then we calculate the z-score, which ends up being negative 2.475. Now, since that's a negative z-score, we're actually talking about the area of the region below that z-score. So we can use table A or technology to get the p-value that is associated with that z-score. And so if we use a calculator, you would do normal CDF. And since we are looking for a difference in one direction, remember our alternative hypothesis was less than zero, you have to go lower is -1,000, upper is the z-score, mean and standard deviation. You get 0.00675. If we use table A, we would get 0.0066. And again, here we don't have to multiply that by 2 because it's not a two-tailed test, it's just one-sided. So from that, we get a p-value of 0.00675. And then finally, we want to do the conclude step, which is where we draw a conclusion based on our p-value. So remember, when we write the conclusion, we use that two-sentence structure. First one, you compare the p-value to the significance level and state whether you reject or fail to reject the null. And then you say in context about either having convincing evidence or not. So here, because our p-value of 0.0068 is less than our significance level of zero point zero 0.01, we reject the null. There is convincing evidence of a lower heart attack rate for middle-aged men like those who take GEM than for those who only take placebo. All right, next thing we want to do is actually interpret the p-value. So be careful here. In the conclusion step, you are writing a conclusion. If you're asked to interpret the p-value, that's a different thing. Remember, the p-value is the probability, which we do use that number in the conclusion, but interpreting the p-value, there's a specific way we have to do that. So here's how we do that. Assuming that GEM is equally effective at preventing heart attacks as a placebo, so we assume the null is true. Assuming the null is true, but we set it in context, there is a 0.0068 probability of getting a difference, okay, GEM versus minus GEM subtracted by placebo, or the difference of GEM and placebo, in heart attack rate for the two groups of negative 0.141 or less by chance alone. Okay, so that's how we interpret the p-value, and also how we do the four-step process on completing a hypothesis test in this situation. All right, guys, hope that was helpful. Take care.